Hey folks, Ms. Gosling here. Today we are going to be discussing how to find the equivalent resistance of a series circuit. Let's go ahead and get started by defining two key terms. First, let's define a series circuit. In a series circuit, your resistors are lined up in a row. So, we've got our battery, and let's say we have two resistors. So here's resistor 1 and resistor 2. And you can see that they're all lined up in one closed loop. So that is going to be our definition of a series circuit. A circuit where all your resistors are in one closed loop. Now let's move forward and talk about what REQ means. This little symbol here is the equivalent resistance. And by equivalent resistance, I mean the resistance that you're going to be using when you are solving for Ohm's law with your circuit. Now, for a series circuit, finding equivalent resistance is very, very easy because all you have to do is add up the resistance of each separate resistor in your circuit. So if we have a circuit that looks like this, with our three resistors, R1, R2, and R3, the resistance that we're going to be using when we solve for Ohm's law with this circuit is REQ, which is going to be the sum of the three separate resistances. Let me show you how with an example problem. So for the circuit below, we are going to find REQ and then use that to find the current running through the circuit. So let's go ahead and start by listing out our givens. First, I know that the voltage in my circuit, V, is 50 volts. I also know that I have two resistors, which I am going to go ahead and call R1 and R2 to differentiate between them. I know that they have resistances of R1 of 10 ohms, and R2 has a resistance of 20 ohms. And that is going to be all that I know about my circuit. However, I can also identify this as a series circuit because all of my resistors are in one loop. So now let's go ahead and list out our unknowns. For this problem, my unknowns are REQ, the equivalent resistance, and the current I. So now I'm ready to go on to the equation step. So first I'm going to go ahead and write out my equation for REQ. And again, because this is a series circuit, I know that REQ is equal to R1 plus R2. And then, to find my current, I'm going to use Ohm's law. So V is equal to I times not just any R, but times REQ. And that is where my equivalent resistance is useful. I can plug it straight into Ohm's law without having to do any weird parentheses or anything like that ahead of time. So now I can go ahead and move forward to my substitution and solution stage. So I'm going to go sub and solve, and I'm going to start by solving for REQ. Now I know that REQ is equal to R1 plus R2, so I'm going to go ahead and plug those numbers in. So we've got 10 ohms plus 20 ohms, which gives us an equivalent resistance of 30 ohms. Now, plugging that into Ohm's law, I'm going to write 50 is equal to I times REQ, which I just solved as being 30. And I'm going to go ahead and solve for I by dividing both sides by 30. And what I'll get is that I is equal to 5/3, or about 1.7 amps. So now you know how to use REQ to find the current running through your circuit. Let's do one more problem, and this is going to be like our previous problem but backwards. So in this problem, we are going to take the current running through the circuit and use it to determine the value of our unidentified resistor, this mystery resistor right here. So it's very similar to the previous problem, but again, backwards. So let's go ahead and try it out. So let's start with my givens. And in this problem, I know that my voltage is 50 volts. I know that my current is 1 amp. And I know that R1 is 10 ohms. For this problem, my unknown is, again, my mystery resistor, which I'm going to just call R2 equals question mark. So let's go ahead and write out an equation here. And the equation that I'm going to use is I'm going to start with Ohm's law. So I know that V is equal to I times Req. And then I also know that Req is equal to R1 plus R2. So what I can do is I can substitute this equation for Req into Ohm's law, which gives me V is equal to I times R1 plus R2. And then I can go ahead and solve for R2. So first I'm going to divide both sides of my equation by I, and I'll get R1 plus R2 is equal to V over I, and then I'll subtract R1 from both sides, which gives me R2 is equal to V over I minus R1. So from here, it should be pretty quick to substitute and solve. So let's go ahead and substitute and solve. So I'm going to leave R2 as is, and I'm going to go ahead and plug in all of my givens. So V is 50 divided by my current, which is 1, minus R1, which is going to be 10. And that gives me R2 is equal to 40 ohms. So there you have it, folks. In this video, you have learned how to find the equivalent resistance for a series circuit and then use it to solve problems involving Ohm's law. You have also learned how to take Ohm's law and use your equation for a series circuit to solve for a mystery resistor. So now it's your turn. Go ahead and give it a try. Happy solving!